All right, we figured it out.
We got it. We're there.
Technocat, it's all up to you. You decide how many you want to generate.
Yep.
All right. So for returning functions, so here we have a distance with reference and a distance method. And in the distance method, we're taking 2 points and we're going to return a double. And it's going to do the square root of the math.pow and blah, 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 blah. That doesn't matter. We don't care about what that's doing. We care more about what's happening here. We have a method named distance with reference. Reference is a point. And this method is going to return a function that takes in a point and returns a boolean. And that's what this method is going to look for. So here we can't just say, hey, return true, because we are looking for a point, comma point, and it returns a boolean. So we need to define the point here, and the point will be d1, d2, and whatever we're gonna do here, this right here is going to tell us, hey, we're going to return a boolean now. So we open up the braces, and this is the code block basically for that function, or for that method. Well, I'm gonna say function because method is here. But for this function, this is the code block for it. Anything inside this code block can happen. Just keep in mind that at the end of this code block, you will need to return a boolean. And then you close the code block here because, again, we just want to return something that takes in a point and returns a boolean. Just a very quick explanation, a quick rundown. Did that make sense? Are you still confused?
Right, and somebody asked about recursion and how it affects the stack. Basically, every frame will be open in recursion until you start going back and closing the frames. So if I recurse 3 times, all 3 of those frames will be open until I hit the base case and start going backwards. That's just kind of how it works on the stack. So if you're told to stop in the middle of 3, all 3 of the prior frames will still be open. The only time you'll ever see just one frame is either right after the first frame, you stop right after the first frame, or right before the first frame closes, because that'll be the last frame to close.
Okay. Are there any more questions for Gen Algo or LO3 content? Because we are going to move on to everybody's favorite topic, linked lists.
Okay, you jokingly say that, but that is actually one of my favorite topics.
I love linked lists.
Linked lists are absolutely fantastic. All right, so let's, Leo, go to the sketchboard.
Oh yeah.
Yeah, because we'll just do it on here.
So,
welcome to our sketchboard.
So Tim, we're talk about hold on. There's one more question. So for LT5 with the function that is being written happening all in the return function. So I can't answer. Well, we can't answer specific LT5 or LT4 or whatever. How many ever LTs there are? 6. You should take that to office hours.
Yep.
Now we go to the sketchboard.
Okay, so I'm going to put a link in chat for everyone to get onto the sketchboard. You won't be able to draw on it, but you'll be able to see Leo and I drawing on it for later. So if you guys want to take a screenshot at the end or whatever, if you guys want to see this at any other point during the time, because we're going to put link lists on here. So there's the sketchboard. You're more than welcome to join. Again, though, you won't be able to draw on it. Leo and I have that distinct fun.
I need the link again, Logan.
Bro, you need the link again? Did you just join the link?
I
sent it in Twitch chat, man. You're fine because you signed into your account. You're on the team.
Oh, I forgot.
Yeah, you guys can see our beautiful drawings from earlier.
There really was no drawings.
No, there's definitely some.
Okay. All right.
Is that you that just made the box?
I did not make the box.
Wait, who just made the box?
I think I made the box from a while ago, though.
Did you just move the box?
Yeah, I'm moving the box.
Okay, I'm making sure. Okay, so let's talk about linked lists. So we're gonna talk about this in terms of a box. So this is we're linked list. No, that's not what I want you to do. Can I just like copy this? I can. Even better. Okay. So we've got two linked lists. Is there any actually? This is a very good question. Is there a way for me to presentation? Only available on private boards. Sick. Is there a way for me to like turn all of you off? You know, it's fine. It's whatever. Okay. So linked lists have a couple of things in them. They've got a value. They've got a next.
Just freehand this.
Yeah.
Make it bigger, see? Oh, there we go.
Okay. They've got two things in them. These two things are super important. Technically, the whole VOD will be available for 2 weeks after airing on Twitch, and then it should go on to YouTube. We've been a little bit behind on YouTube uploads, but they should go up today for the last 2 weeks. So yeah, thumbs up. So they've got a value and a next. The value is an important thing. The value basically says, hey, this is the value of what's in the linked list. So if you were to have a regular list, every index would have a value. The difference, though, is the linked list has this next part. And this next part says, okay, whatever's in here, this is the next thing. So if this is the next one, then it will refer to this. And this will also have a value. And it will also have a next. And let's say this is the end of the let's say this is the end of the linked list. This will just refer to null. What are we? Oh, thank you. So, wow, why is this kind of super buggy? It's okay. So, this is what our linked list will kind of look like. Why is space not? Okay. I'm just going to stop touching buttons. I don't know what does. So, this is what a linked list looks like, right? So, we'll have this value. We'll have a value and a next. So our linked list class will look a little bit like it'll have a value called value, and if it's a linked list of strings, we'll take in a string as our value. If it's a linked list of integers, we'll take in an integer as our value. And it'll have this next value built into it that is actually just another linked list node. So let's hop over the slides for a minute, and then we'll come back to our sketch pad. Let's do this. So I'm not going to go over how it gets stored. Basically, the TLDR of how it gets stored is you just don't want the TLDR of how it gets stored is that you don't they don't get stored contiguous pieces of memory. So a regular list would get stored. So let's say your head was at 506, index 1 would be at 507, index 2 would be at 508, 509, etc., etc. So you need to basically declare I need this much space in the memory beforehand. Right, you need to say, this is how much space I need, because otherwise you're going to butt into something else. A linked list allows you to go anywhere in the memory, right? So it allows you to say, okay, our first index is at 506, and the next value for that is the value that's at 795, which is another linked list node. So our class for linked list is actually super simple. It's just, it takes a value of A, which is any type, but it'll all be the same. It takes a value of A, and it takes next, which is just another linked list node class. So when I say, let's say I have a linked list node called X, if I do x.next, that will just give me the node that is next in the list. And this is kind of how you build it. So you just declare the first one as an integer. So there's a linked list of integers. So our first one is going to be 1, and it's going to point to null because we don't know where it's going yet, right? Then we're going to make a new linked list node in my list that actually refers to this piece here. So this refers here, and this refers to this one. I know my drawing is a little terrible, but it's okay. So they all refer to the previous one, so that way in the end we'll have a linked list of 5, 3, 1. So Yeah. So linked lists are a little bit more difficult to work with, because they just are. Because you don't have the same like dot length. That's not a thing. Dot size isn't a thing.
Well, I think dot length is a thing.
No, it's not, because they're nodes. They're individual nodes. It's
Oh,
not. It's
you're
not.
right. You're
You're
right.
thinking 250 linked lists.
Yeah.
Dot. Let's say I want to just like let's say x of 3. That's not going to give me the third index in x. The fourth index in x, right? So it's kind of difficult to work with in that matter. So how do we do that? So our size, we use recursion. We say we're going to keep going until we get to the endpoint. The end node is always defined as the one that says that next is null. There's no next point in the linked lists. Okay, so we'll continuously recurse until we get to that point. We'll say that that's one, and that every time we recurse back is one more. How do we change it to a string? Well, the exact same way using recursion. We go to the end when it's defined as null. We're just going to say the value.toString and then continuously add it back. This is where recursion comes in really helpful. Apparently there's a debugging demo here. Oh, Leo.
Oh, a debugging demo.
I just realized you couldn't see anything.
No, I can see it. It's fine.
I sent you the parsec link.
Okay.
So let's say again, right, when I was saying that you can't do x of 3, right? It's kind of difficult to say, well, I want the third index, right? So we have an apply function. We say if I is equal to 3, if I is equal to 0, we're going to do that. Otherwise, we're going to continuously recurse down until that point. So let's say I want index 3. So we'll go here and we'll say and this will be 3. That's a really bad 3, right? So is I equal to 3? No. So we're going to call this now with 2. And we'll call it with 1. Then we'll call it with 0. And it'll hit it. And we're going to return whatever this is. We'll return this linked list node. As Jesse writes here, apply of 4. So x of 4 is the same thing as this dot next dot next dot next dot next. And I think in this case... Yeah, no, it's the same as that.
I think it's the same as that.
Yeah, because I changed the number. But it's the same as writing dot next a million times, but obviously you can't really write dot next a million times, because, well, you don't know how many times you'll go dot next. This lets you put in a parameter of how many times you want to go next. The cool thing about linked lists is inserting. So let's take this right here. We want to insert a 2 in this list after 3. Let's just take this example right here, right? So if I want to insert a 2 in this list after 3, normally with immutable lists, with our normal everyday lists, we'd have to go, okay, computer, I need memory. I need one more size because I'm going to put something in there. We're going to copy the beginning part. We're going to put a 2 in. Then we're going to copy the end part. That's super inefficient and really stupid. So what we're going to do is we're going to make a new linked list node. Okay. We're going to say that its value is 2 and that its next is actually whatever the thing we want it to be next is. So now there's 2 nodes that actually refer to this one node as next. Okay. But then the sneaky part is what we're going to do is we're going to go into the node that we want this to be after, and we're going to say, hey, remember what you said was next? Remember you said node 1 was next? Yeah, that's not true anymore. We're going to go here and we're just going to go, no, this node is next. And so this part here doesn't exist anymore. Right? That connection between node 3 and 1 doesn't exist. We just pointed this node 3 to this new node we made, and we pointed this new node to whatever the next one was. So it's only one change that we have to do. We make this new node, and then other than pointing it to wherever we want it to go, we just change the prior node in the list to point to this node. So Jesse shows this here in some stuff. Basically, we do the same thing. We insert it here. We change the pointer from node 3. We change it from here. We change it to node 2. And we change 2 to 1. We just kind of redirect it a little bit. So as we write here, insert element A, we just say this dot next, whatever this is, its next is actually this new linked list node, with whatever the normal next is. If we want to delete a node, it's super simple. we basically just say, hey, remember you said that this was the next node? Yeah, nah. We're just going to go around this to here. We're going to go around this over to this node, and then it's just like you can't actually access this node unless you access this node specifically. And what you can even do is you can update this node to say next is equal to null. So it's totally separate, but you don't have to do that because the only way you could have accessed this was going to this for node and going next. Now that this reroutes to here, doesn't matter. If you want to find a value, you're going to do it recursively. You're going to say, if this is the value I'm looking for, return this. Otherwise, if this is null, it doesn't exist in the list. Otherwise, we're going to recurse again. On to the next thing.
Recursion.
Yeah, there is a lot of recursion in this, but we give you a lot of recursive functions, and you should be able to understand the recursive functions after the first time or two. So here's a super interesting thing here about recursion versus iteration. So Jesse makes a while loop here, saying the node is not null. If it's not null, if the value is defined, we're going to return the node. Otherwise, we go to the next node. So we're just... You can write the same thing in recursion here, and you don't need any loops. Which, in this case, is going to make your code run considerably nicer. You can call for each on the entire list by defining this and saying if this is we call f on the value and say if the next value is not null, we're going to recurse again and go again. We can do all the same stuff that we do on a regular list. It's just a little bit more complicated, but they get very convenient later when we want to store things like trees and graphs, which you guys will learn about on Friday and Monday?
Something like that, yes.
Something like that. Within the next week. We'll talk about graphs and linked lists. Yeah,
we'll talk more about...
We'll talk about trees next week. Yeah, trees, and then we'll talk about graphs the week after.
Yes. Next week will be a trees lecture.
Only arbor trees, man. Only arbor trees.
I want apple trees.
Okay.
Isn't arbor trees like that guy from Adventure
I have no
Time?
clue. It just came into my head and I was like, screw it. I'm saying arbor trees. So, I'm not going to go through everything. I mean, actually, this is the last one. But point being, you can do all the same stuff that you do to a normal list to a linked list. The difference is inserting it, super easy. Deleting something from it, super easy. And the most important part is an extremely efficient way to store data, and it doesn't require you to have a giant block in the memory. You can put it anywhere in the memory, you can go wherever.
Well, yes. Basically.
Shut up, Leo. Okay. Does anyone have any questions on linked lists? I'm opening IntelliJ if somebody wants us to do a little bit of coding. I'm fine to do that. I just need to, not show all the quizzes. I know for a fact this time that that's actually the last thing
we would also need something to code.
Yeah.
I don't know about you, but I'm absolutely dead after that 250. My brain has
brain just doesn't exist.
Has gone to mush. Brain is equal to mush. See, I drew a pretty good one. I'm looking at your screen right now.
Yeah. Just waiting for IntelliJ to open.
I see no questions in the chat.
I'm seeing absolutely none.
I am going to assume that you all know linked list completely.
And if you don't, it's because you're extremely overwhelmed and you're going to come back to this and watch this in like 3 days when genetic algorithm isn't due or your learning tasks and lecture objective questions aren't due.
That is also a possibility.
A very viable possibility. Not hating on people who come for hearing it the first or second time here and then coming to hear it again.
Yep. Not hating. We like it when you come. This is you just opened up. Oh.
I can't. I don't choose what it opens. It just opens the last thing that I had open.
I just real, you know, because I'm looking at your screen and I thought that was the stream, and I was like, wait a minute, you just opened up all the quizzes for this in front of stream, and
Nah,
I was very worried
I
for a
turned
second.
it. Leo.
Yeah, I know.
Yeah,
I completely forgot.
I switched it.
Can we talk about Project 4 clarification?
If you're talking about Jesse's Project 4, it's I don't think it's officially done yet.
Yeah, I would also, if you're talking about Nazaryn's Project 4, I could probably give you like a quick rundown.
Oh, Jesse's might actually be done now. That's very possible. It was not done last time I checked.
Yeah, last time I checked, it wasn't done either.
Well, I checked like 3 hours ago.
No, wait, go down again one more time.
Yeah, no, it's
Still not done. Okay.
AO2 for this is not done.
Yeah. He's still deciding.
Is this done? It is. We could talk about it for like half a second, but I don't want to spend a huge amount of time on that if other people have questions that are more related. If that makes sense. I expect to.
Okay, no, go ahead. You
I
explain
expect. Well, in a second, I expect to actually see a huge dip of like people that come to this review session this week because GA is doing like 4 days for us. And you guys have lecture questions due on Friday. So
yeah,
I expect to see a dip in attendance today. You're talking about LT1. If you need a quick clarification, Euclidean distance. There's a formula for it. You just need to Google it.
Just Google the formula. Don't.
Yeah, it's just literally Google the formula.
Do not waste your time trying to do.
Actually, it says the formula in like parentheses: square root of the sum of the squares of the differences in x and y. It's the distance formula you learned in high school. It's like the square root of x1 minus x2 squared plus y1 minus y2 squared. It's that formula.
But they just put an actual name on it.
Yeah, they just made it fancier.
Also, Nazaryn's last project is very fun.
It's this.
It is also not difficult at all.
Here, Muffin Man, I got you. I'm gonna just throw it in here because I don't feel bad because it's just literally writing something. It's just like a Google that I can.
Yeah. You are most definitely going to enjoy Nazaryn's project. And it's a very simple project.
Is you guys pathfinding?
Yeah.
Yeah, so
and Maze Solver.
Yeah, we've got yeah.
But you have basically a different version of it.
Yeah. No, he's being serious. This is actually a fun project.
Yeah, it's actually a fun project. Especially Maze Solver. When I first did Maze Solver, it was very fun. When I figured it out, it was very fun.
Muffin Man, that's the formula you're looking for. If you Google it, you'll find it. It's not that big of a deal.
Yep.
It's actually super simple.
It is also, so again, I'm going to reiterate, it's also much easier than genetic algorithm.
Yeah, I figure everybody is actually still struggling on GA if you're part of Jesse's class, and I figure if you're part of Nazaryn's class, you're struggling on learning lecture questions.
So yesterday was our due date, but we have
well, you get lecture questions due on Friday, so
lecture questions due on Friday plus there's
how do we know which is x1 though? It doesn't matter which is x1, which is x2. Just use the same variable for each. So if you use x1, make sure you use the y value from that like coordinate pair as y1. That's all it is. It doesn't matter which one's x1 versus x2.
Yeah.
Actually, just make sure you're consistent with your stuff, because squaring it'll just basically do the absolute value of it, so it doesn't really matter. You won't get a negative distance. If you got a negative distance, you've done something wrong, like terribly, horribly wrong. Yeah, no, it's a super simple thing. That's why I don't have an issue like answering questions about that, because that's just like
lost. He just said I almost died doing Maze Solver. That is, I don't know who you are, but that
I assume a prior student of ours.
I would doubt that.
I assume it's a prior student.
I would assume so.
All right.
Look, you know what's
So
so cool?
what?
I just wanted to mention it really quickly. I have the same computer background.
Do you
I
actually
used to, at least. I used to, at least. Yes.
on the double
I'm a
monitor?
I'm a massive I'm a massive Star Wars fan.
No, I like honestly. This is just the one that I like switch it every like 2 or 3 weeks, and this is just the
Oh
one I
really?
like landed on. Yeah, though this is the one I normally have pulled on. I'll just show you it. You only see half of it, but like
That's
you
fine.
can kind of imagine what the other half looks like.
Me having 3 monitors is really helpful. So
Yo, folks, y'all got questions? We possibly have answers.
sort of.
Maybe.
No, we definitely have answers.
Are you sure? It's
Maybe you do. Maybe you do.
this one.
Oh,
So
I expect that.
it goes across both monitors.
Yeah, I expected that.
Yeah. I also really like this one, which
You know,
splits on the.
I can't put one because if I play games for too long, then my computer crashes. I can't. It's awful.
Yo, if nobody has questions, we're just gonna dip. It's super simple.
Yeah, especially if you completely understand linked lists, then we're dipping. You almost destroyed me.
It's one of the reactive backgrounds. I was trying to get it to react a little bit, but
I know. I can tell.
Can we ask GA?
GA?
Yeah, you can ask about GA, but
Everyone wants to know about GA.
We reserve the right to say absolutely 0% of things.
Yeah, sure. You can ask anything about GA at this point, but we also reserve the right to just not answer you.
Yep.
How is Nazrin's class doing? I will not answer that. For LT4 in GA, do we need to return just ratings or rating and energy rating? And
you need to return a list of songs.
I
However that works, that's what you need to do.
And Sugar Bombs, how do we test line? I'm confused on what you're asking.
I'm also confused.
Do you mean so assuming you have the incubator and cost function done, you would test it like you would any other method, where you call genetic algorithm and see if it returns what you expect it to. Right, I understand it's for the testing opportunity, but exactly what do you mean by how do we test line? What are you doing, Logan?
Me?
Yeah.
I'm trying to see if this works. How do we do it? I'm not telling you how you do a test.
How do we do it? We cannot tell you how to do it. If you mean, I'm confused on what your question is asking. Are you asking how do we test? Because that, you shouldn't understand how to test at this point. And Nazrin section has GA as well. Yes, both sections have genetic algorithm.
Mm-hmm.
I think your guys' is
it's a little bit different, but it's the same general vibe.
Is yours due? Yours was due Sunday, right?
Ours is due Friday.
Okay, yeah, ours was due yesterday. So. Genetic algorithm is just the best test to see if you understood LO3, in my opinion. Oh, so both classes suffer.
Yeah,
Nice.
Absolutely, because it's a super important project to do.
This is one of the best projects. Regardless of how much you suffer, just doing the project itself is a an experience, I would say.
Hold on, I
Oh,
never said GA was fun.
all TA said GA was fun. I found it kind
Hold
of
on.
boring though. I
I
said GA was
I
fun.
never said GA was fun.
I thought it was fun. I thought it was very fun.
Super Panda, out of curiosity, who asked about the TA application process went for you guys? Yeah, sure, because no one else is asking any questions.
Yeah. Why not?
Yeah, so I got hired in after spring of 2019. No. Yeah. That makes sense, I think. Because last year was 2020. Yeah. I got hired after spring of 2019, which is when I took the class. My interviews were in person. Leo can tell you more about. Actually, I can tell you about the online interviews too, because I did those too. But you'll submit a resume and stuff to Jesse at the end of the semester and that kind of stuff. And you get asked to. We used to ask to make a presentation about like what is going on about like a topic. We used to, yeah. Do we still do that, Leo? Is that what we did last semester? I don't remember.
So what happened with me was I was sort of an emergency hire. I put quotations on that because that's not completely true, but so what we ended up doing was it's more of you have to talk and try to teach a learning objective.
Yeah, and you teach it to a small group of TAs who are going to be absolute awful humans to you. I think Leo tried to interview me, and I was an awful human to Leo.
Oh yeah, Logan completely destroyed
I am the best interviewee.
He
okay.
really asked some crazy questions.
All right, hold up. Can you guys go over? I don't understand GA. Okay, Trippy, if you don't understand GA, please go and watch the review session, which I think is on YouTube now. It's not on YouTube now, Mike. Okay. It's either on this channel now, or it's going to be on YouTube tonight. The best way to do it is to watch that. It takes legitimately an hour and a half to explain the correct way. The two things that I can tell you is look at the tutorial point article that's inside the document.
I'm looking at it again.
Look at the Wikipedia thing and watch the review session from 2 weeks ago in which we talk about it. Let me send a message to Mike really quickly. Yo, students are asking.
So I'm going to be putting the link into the chat right now. Definitely look at this tutorials point link.
Yeah.
It helps a lot.
It does help a lot. And read the thing like 7 times and mark it up, the document. Yeah. Because that is how you get through it.
Even in your code, write comments and stuff. They're like depicting all the steps and what you need to do. It helps a lot.
Alright, can we go over Maze Finder? I need something more specific than just going over the entire thing, but if we get to a point where we don't have questions again, sure.
I don't know if... Oh, I think they're also talking about Nazarene section, so I have no problem going over it. I just want to answer all the questions first.
Leo, I know Maze.
Well, you know Maze Solver too. What am I saying? You're the only one who knows it better than me, if anything, right now.
If we get picked to be a TA, but it's for 115, can we decline? I mean, I guess.
I guess, but don't, I would say.
Yeah. I mean, yeah. Maybe a question directed more for Jesse, but so Jesse says the TAs, if we apply, are most likely to be one team. It would be better to have a presentation with 15 content in mind. I mean, no. When I presented, again, I had to present on a topic. I didn't have to present a learning objective because there were no such things. So when I presented I presented something, I just presented loops. And I did like all types of loops, but I did them in Python, I did them in JavaScript, and I did them in Scala. I did it like bridging through all the classes. Honestly, it doesn't really matter what you present. It's more of a how do you present? How can you get your point across? Like how do you deal with students asking you questions? That's actually a really big one, is how do you deal with people asking you questions, whether they're well thought out, really good, two paragraph questions, or whether it's like code no worky. and like
Yeah.
what you would do in different situations as a TA.
And for those of you who think you need to understand every single piece of code that you're given to be a TA,
You
that
don't.
is not at all the case.
Like
Not at all the
full
case.
full disclosure, when I took the class, I didn't do genetic algorithm. I super understand it now, but I've TA'd this course for 4 semesters and I understand it more and more every single semester, right? I understand it at a really, really high rate now. But when I had finished, I didn't understand it. Something that Jesse will say a large amount of the time is that some of the best TAs are people who did not do so well in the class. Because I'm gonna call out nobody here actually. I'll use myself in this example. I don't think I do this, but I'll use myself in the example of like if you ask me like how do you make a variable, like people who get it immediately, like TAs who get it immediately, will just go like, how do you not know how to make a variable or something like that? Or like they'll forget that there's steps along the way, or if you're like asking something, there's steps in between them that you don't 100% do because you just do it automatically. So some of the best TAs are actually people who don't do super well in the class and who take their time on these kind of stuff. So I don't know. I find it kind of dumb that there's a chance to be a TA for 115. I'm applying to be a 116 TA, not a 115. I understand they're gonna need more TAs. So it's not that. So it's just they pull from the same pool. We send around a sheet that's basically like which do you prefer, which class do you want to be in, and there'll be a bunch of people who are like, yeah, I don't care which class I go to, whether it's 115 or 116. There'll be people who are 116 only, like myself. Like I've TA'd for what 4 semesters now, 3. Fall, spring, fall, spring. I've TA'd for 4 semesters now. I've only ever been 116. But then there's people like Nick McCrae for the other section, for Nazarene section, that flip between 115 and 116 depending on who's needed at what time. So there's definitely a chance that you can be a 115 TA, but you can also just ask to be a 116 TA and you should be fine.
Also, I would say being a 115 TA to start out
It's not a bad idea.
is not a bad idea because so from personal experience, this is my first semester being a TA for 116. It is a lot more difficult than it looks. I think when you're not in this position, you tend to think like things will go smoothly all the time, and you won't see things, or you won't or you're gonna be able to understand everything that's going on. It's actually very interesting. There are some things where you just kind of like lose track of what's going on. So especially with me taking 220 and 250 together, it's a lot more difficult than it seems.
Yeah.
Let's see. Okay.
I'm taking like upper level courses, but like the hold up, let's go from this side. This side. The difficulty of courses is like 115, 116, 250, 220, 331, 341, and then the rest of your classes kind of level off.
Yeah.
It's like a hump that you go over and then it comes down a little bit. So like for me it's not terrible because I'm past the 341, 331 hump and I'm just kind of taking classes that I want to take. Like I have a bunch of work, but it's kind of not like a huge amount of super difficult work. It's just like work I have to do. For Leo, he's doing like super difficult stuff at any given time. Like 220 and 250 are killers. They're both rough. So it's a struggle to balance it all, but like if you really set your mind to it, you can do it. And none of us have like a huge amount of hours. Like I'd say I probably have the most amount of hours in my section, or damn close, and I'm at 15 hours a week. So yeah. As Muffin Man said, pay is optional, so you can either get 4 credits and no pay, or pay and a single credit.
So to go back off the upper level CSE courses, so obviously I'm not in upper level CSE courses. I will be taking the same classes that you guys will be taking next semester and the semester after that. So I can't really say much, but from what I'm looking at for 220, 250, this seems like the hardest it can get, in my opinion. Obviously, I have no idea for 341, 331.
331 is harder, but 341 isn't, so it kind of levels itself out there.
Okay. So, again, like, I don't have a massive amount of hours, but it does. So I've noticed being a TA for 116 has helped me in some of these courses. especially when I have to debug or when I have to like look at things and understand them way more than I thought I needed to. So, like again, the balancing, it just takes practice, keeping yourself to a schedule, making a calendar with stuff that you want to put on. Those are some good things you can do to keep yourself in balance and in check throughout the entire semester. And then you forget how far the semester is in, and then you realize there's 2 weeks left, and your death is slowly came. But it's okay. Yeah. And again, if you guys have any other questions, especially related to course content, feel free to ask them as well. We went over linked lists super quickly, but that's because, again, there are some people who are probably just working on genetic algorithm and working on just trying to get their lecture questions done and stuff. So,
what about burnout though? Because this semester has been full of it for me. Yo, we're all burnt out. There's like this like excited about doing classes and stuff. This is a facade we put on for 2 hours a week right here, and that's it. Other than that, we're just super burnt out. That's like half bullshit. Like it's rough. Like burnout's rough. Like we're all facing it at the same time. When you're in person, it's not as bad, if that makes sense. I mean, when you're constantly at home and doing online class, it's like, for me, it's me TAing is the same as me doing classwork, and it's the same as me doing like fun, because like I play video games for fun, right? So it's like sitting at this computer the whole time. When I'm at school, it's like I'm in my dorm room, I'm playing games on one computer, or I'm somewhere studying on my laptop, right? Or if I'm doing 116, I'm physically in the lab room or physically in the office hour area in Davis. Like I'm not. It's like separation, and that helps with the burnout a lot, and also the fact that you get a break, and you can kind of make a little bit better breaks for yourself when you're on campus. Just being on campus helps a lot with burnout. I think for me at least. So, and also making time managing correctly helps with that too. My burnout took a lot longer to hit because I time managed really well early in the semester, on like how I was doing my work and how much work I was doing at a given time, and like not waiting till the last second to cram everything in. So that helped a lot for me, but it results may vary for anyone.
So, when you say the semester has been full of burnouts, I would not say that. I would say for me, it's mostly been now, where assignments are due. You got like 2 weeks of class left, and now suddenly you got to get stuff done. And then that's where my burnout has mostly been. But at the beginning of the semester, I was fine. A good way to counteract burnouts, honestly, taking a break, like going out for a walk, hanging with friends, do something other than school, because it happened to me last semester where I missed out on a lot of good opportunities with my friends, and that was because I kept telling myself I was really busy with schoolwork, and I just kept telling myself like I'm busy, and then I moved to Buffalo. I got my own place, and I don't see my friends anymore, and they were constantly asking me to hang out. So if there's one thing I would suggest, is just take time to yourself, kind of take time to do stuff that you want to do. So that's what I got for burnout. Not bad. Am I still on yours, Logan?
What?
For a second, I thought I was on your parsec. But then now I am.
I was like,
what are we looking
pretty
at?
sure you are.
I just
All
realized.
right, so if we don't get any questions, we're gonna wrap up soon. I gotta make a target run tonight.
I thought you made the target run yesterday.
Yeah, but they didn't have any of the shit I needed. So
what makes you think they're gonna come today?
Well, because I ordered the stuff and it said they're ready, and they didn't send me the email that says your shit isn't there.
Oh.
They like sent me the right stuff.
Oh, okay.
Like
right.
It's not sent me the right stuff. It's like I have to go get the right stuff, but like
You just have to go get it, but they
Yeah.
don't send it.
Yeah.
I see. All right. Are there any last minute questions at all? Any last minute questions before we head out?
Or not last minute questions, and we stay a couple.
Or
minutes
not
longer.
last minute, and we just
Yeah.
stay here for longer.
Yo, Leo, F1 comes back this weekend.
I know. He told
I'm
me
so
about
excited.
that. I'm actually very interested in it now.
I know. I got you involved. Shout out to Herbert. Always shout out to Justin Herbert.
Who's Herbert?
Justin Herbert, quarterback for the Los Angeles Chargers.
We all hate Justin Herbert.
No, get out of here. Do I need to turn on the things we don't talk about thing? Did I delete that? I might have deleted it.
You might have deleted it.
Oh, that's so unfortunate. I think I deleted it. Last semester we had when Jacob and I did this, we had a bar that's along the bottom of the screen that just was like things that we will not talk about. And like if the Bills lost, it was like we will not talk about the Bills. The Chargers lost, we will not talk about the Chargers. For a while it just said we will not talk about DeAndre Hopkins or Kyler Murray.
Oh well.
Yeah. All right. We're
remember
peacing
that
out then because nobody has questions. So
Yep. We'll see you next
See
week,
y'all.
guys.